So while we're waiting for the next speaker, for how many of you is this their first Viz conference? Oh, wow. First Viz conference ever or first Viz conference in person?
In person.
Great. There's Klaus. Is this your laptop? Okay, great. I'm just going to quickly announce you and we'll get started. Okay, so our next paper is going to be using large language models to generate engaging captions for data visualizations by Ashley Liu and Klaus Müller. And Klaus is going to give the talk.
I can get logged in. Oh, I'm no longer. Okay, hi everyone. So this is work I did with a student who was here in my lab for the summer. She's from our Rochester Institute of Technology. Her name is Ashley Liu. She couldn't come here, so I'm presenting her work. So this was motivated by these kinds of problems we had, right? When you look at these captions in our publications, right, they're usually very miserably small. So this is actually one from my own paper, the battery data set visualized with NLVIZ, okay? And then there's another one from the same paper, the battery data set visualized with NLVIZ Deluxe, which is the other thing. And then there's another paper that I wrote, Pareto optimal graph spreading. It doesn't really say anything. What the problem with this is, these are my own papers, okay? Making fun of myself, okay? Don't be offended. And so basically, this is geek speak, right? There's nothing really in there that tells anything about the data at all. Right? And the data domain is not connected at all. This is just a bunch of engineers talking to another audience engineers, but it doesn't really show anything. What actually these data are very exciting, but don't talk about it all, right? So when you look at this, and this you can read the study by Michel Borkin, right? It's really a good study. They showed with user experiments, they showed that actually paragraph and title and label, paragraph is actually the third most thing that people recall, right? It's the data comes after. That's amazing, right? The data comes after. So because you look at this caption, and then you look at the data if it's actually true, right? This is sort of what my thinking at least of it is. So so how can us geeks become these cool journalists that write these beautiful captions that are so engaging, right? How can we do that? So luckily there's something called GPT-3, and already heard about this before, right? There's this how that can save our butts, okay? So GPT stands for third generation generative pre-trained transformer. So it's a language prediction model, right? So it's like basically think autocomplete on steroids, right? It's the ultimate autocomplete. And what it does really, it works in a next token generation process, right? It basically, you give it something and then it tries to predict the next word based on probabilistic reasoning, right? So from all the corpus, it tries to find that word that fits best after that, right? And then it puts that there, and then there's the next token it predicts and so on, right? So the number of tokens that are allowed with GPT-3 are with the input and what it outputs. So it determines the cost. Actually, you have to pay for this after a while, and the time it takes to actually get the caption. So you'll have to be very very, very attentive to how much input you actually provide to get the right output. And this is called prompt engineering, right? So the prompt engineering is actually the key task in this. So, okay. So our initial experiments were like basically GPT-3 doesn't really do well with numbers and aggregate things like that. So if you give it some numbers, it doesn't really know what to do with it, right? I think I read somewhere GPT-3 can even predict that 3 comes after 2, stuff like this. So you need to do some analysis before you give that to GPT-3. Okay, so next thing. So we provide basically this kind of information. We take this, we use only scatter plots. What we do basically, we provide regression coefficients and outliers and Pearson's formation and the number of clusters. So we give it some stuff to deal with, so it doesn't have to infer it itself, because it can't, right? So we give it some stuff, and then we have these 3 tiers of prompts, right? We basically, the first tier is just a template, any template that can be auto-filled with these measurements we take, and there's no human input at all, right? We just analyze the scatter plots, we fill the template, done. And then the tier 2 is the template and some instruction, like a little bit, some sentences that describe the specific talking points that we'd like GPT to ramble about. Okay, there's a little bit some human effort needed. And then the third one is where we really engage in the question and answering. We really do Q&A with GPT. We start to converse with the bot, right? So that takes more time. So give you like an example of this clip here. So we took like scatter plots like this. This is GDP per capita versus healthy life expectancy. And as you can see, a nice correlation. There's like Swaziland is like an outlier. We detected that. And then we went and created our first prompt. Basically, the first prompt was just this template that I show here, like just a regular template filled in with the stuff we measured, and we added some stuff in there, like other attributes that are in the data set to give some context, right? We heard about the context in the last in the keynote. Basically give a little bit of context, what actually is the data all about, right? Not just the attributes only that we had the scatter plot about, and all these information that we expect that we got out. And the generated caption we got in tier 1, just throwing the template at the GPT-3, we get the higher GDP per capita, the higher the healthy life expectancy, exclamation mark. Well, it's a beautiful caption, right? A little bit witty and smart-assy kind of thing, but it's a good start, right? So we knew we had to do a little more than this, right? So the prompt 2, right? So we've added basically to the prompt that we had, we added this, like the prompt that you saw before, the long templated prompt. The caption should include information explaining causes of the large positive correlation, why there is an outlier in detail. So we just added that and just throw it at GDP. And then we really got something very, very nice, right? Look at this, right? Strong positive correlation. And then we heard about outliner data Swaziland, which is a lower healthy life expectancy than would be expected. This is likely due to the high prevalence of HIV in the country, which has significant impact on health of the population. Beautiful, right? This is actually something you get, you read like a paper, like a New York Times article, that's what you would get, right? Like a nice explanation that you probably have to research if you didn't have GPT-3, right? Beautiful. And then, so it becomes a data journalist now. Then we want to dig a little more, right? Added some more prompts, like we added more stuff to the prompt that I should show you. Are there any other reasons why Swaziland has a lower healthy life expectancy? Why does Swaziland have poor sanitation? Why is the reason? So it basically was prompted by the GDP, what it returned to us, right? And then we got a little more out of it. Swaziland's poor nutrition is likely due to a combination of factors, including poverty, food insecurity, and the lack of access to nutritious foods, right? So it's, this is a nice caption, right? It's a little long, but it's has some, you learn something from this caption, right? Something you couldn't get from the visualization itself, which is a good thing, right? So what we found out was there's this something called temperature parameter. When you set it to 1, we set it to 0 initially, but you also set it to 1, which basically gets more diverse response. Every time you run GDP-3 on a prompt, you get a little bit of a different response. So it takes more risks, they say, right? And then sometimes, however, what we also found out, sometimes it gets confused, right? And sometimes actually it's not true what it returns. When you do some fact checking, you find out it's actually not true. So we discovered that. And we couldn't blame it, of course, but there's no one you can slap. Like claiming, for example, as one thing, that size is the same even though the data attribute area increases, right? There was one plot like that. So, so it couldn't figure out that size and area are related. They didn't know that, right? It only knows so much. And the bot will also not elaborate. Even when you prompt to do like, tell me more, very, very impatiently, he wouldn't say more. Right, because it didn't learn, I guess, or something like this. So there's more examples in this paper that we have. Then we did a user study, and we showed 11 participants were shown 4 visualization in turn, and they saw all the 3 tiers. And then they were asked to rank them. We found out that tier 2 and tier 3, in terms of the engaging, because engaging was our prime hypothesis, so I want to see if we can actually get more engaging captions out of them. Tier 2, 3, all rank the same. In terms of the relevance, tier 2 and tier 3 were almost the same too, in terms of relevance, what they gave out to the data, I guess. And then 2 more we did on the repetitiveness. So of course the last year was more repetitive because it was more text, right? Okay. And then novelty ranking, tier 3 won again because it did give more novel information out, right? So that was good, right? So here's some other one that we did on this. This was more of a cluster-oriented visualization, and it describes all this stuff here. And it was on average income over spending score, okay? And then it talked about lots of things about this, but I really want to highlight this. These outliers could be due to a variety of factors, such as customers with high incomes who are thrifty, or customers with low incomes who make impulsive purchases. I think that's a beautiful sentence, right? It's like really, really interesting, like something that really only a journalist would write, right? I mean, okay, maybe you guys could write that too, but it's like something you would expect in an article from like in a general magazine or newspaper, right? So, and I open up the floor to questions. Okay, so this is my last slide.
Marty Hurst, UC Berkeley. This is a really interesting presentation because I'm quite interested in how language models are going to affect Viz. I'm wondering if you experimented with varying what kind of input you gave the model. I know you were, in terms of how much of the original data, because you said you use outputs of regressions, coefficients, that sort of thing. How important was it for you to describe that data, do you think, for this interpretation?
Oh, it was just in that template was in there, and then we dug a little deeper, right? We used this. So when it didn't return what we wanted, we basically say, tell me more. Why do you think the regression, or why do you think the rise is higher? What makes you think that? Right? Try to tease it a little bit so it would like deliver something. Sometimes it's so successful, sometimes not. It's really a hit and miss. It's unpredictable, which is the human side of it, right? You ask somebody and they may say something, may not. Political debates, they evade the question and go somewhere else. Because it comes from human data, so you would expect, human-like response. That's my very basic explanation for this. Sure.
So the questions about the longer captions, maybe the second or the third tier. So I think I remember one of them actually talking about, say, the Swiss and about certain things about Switzerland. Did you check? Is it actually correct? Like reflecting what's in the data? Or is that just because the model might see the same text before, so they just use it there?
In the data, it usually was correct in the data, but then sometimes the conclusions drew from the data were not correct. Sometimes. Like there was I think with Swaziland, or there was Botswana was another one. And it had a higher health ranking, but then it somehow explained it wrong. It has also problems with double negatives, big time problems with double negatives. When you ask a question with double negatives, it gets really confused. Okay. Then you can easily trick it. Of course, not the purpose if you don't make a good caption. But fact checking is good. It's good to fact check a little bit. Sometimes, most of the time, I didn't do like a long study where I can say like 10% are wrong. We only really did with three cases.
All right, let's thank the speaker, and we're going to move on.
Okay.
And hopefully we'll have time during discussion to revisit these topics. So the next talk up is by Richard Rath, summarizing text to embed qualitative data into visualizations.
to the room here, but not to the audience online.
Is it good to go now? All right, great, thanks. All right, so hi, I'm Richard Brath. For those of you who don't know me, I've been interested in how text fits into visualization for more than a decade. I recently did a PhD and a book on the subject. In this talk, I am interested in how we fit text into visualizations, not labels, but longer text like sentences and paragraphs. So that might sound a bit crazy. Why are we trying to put sentences and paragraphs into visualizations? But thanks to the previous talk, we maybe do want to. And I also love this quote here from William Cameron, not everything that can be counted counts, and not everything that counts can be counted. This is from the 60s, so great work done back in the 60s by psychologists. So I think visualization is too focused on the quantitative, and there's many reasons why we might want to look at bringing more qualitative data in. Here's a few examples. Subjective data may align poorly with what your objective is. Non-quantitative goals might be more important. On the business side, we might be getting to things that are very difficult to measure. And sometimes the quantitative is not the hard part. In a lot of political issues, we already know what the quantitative answer is. It's the qualitative is where things get stuck. How can we then visualize qualitative data? Well, we can do things. Is this blinking only for us, or is this also online? Or
Every time you're not moving, it's blinking.
pardon? Yes. Okay, so maybe it's working now. Well, we can certainly know all about narrative visualization. In a lot of narrative visualization, we separate the narrative from the visualization, and then these charts can get lifted from their story, used in another context, and all of the story is lost. We can also do uncertainty visualization like error bars or blur, or even adding labels on, but the semantics are lost when we go down to just things like that. Instead, I think we can look towards other areas. So this is the domain of cultural mapping. It's a technique that's come out of the humanities. It's been around for 2 decades. I'm paraphrasing Peter Poole, an early innovator here, who says that cultural mapping goes beyond strict cartography to include cultural resources: anthropological, sociological, archaeological, genealogical, linguistic, topographical, musicological, botanical. And so the results that come out of this are actually, very interesting. We have a lot of text that's directly integrated into these visualizations, and it's proximate to the things that you're talking about. So here's a room-sized visualization down here with a lot of annotations. Here, all the water areas have been replaced with a narrative, for example. And in the Viz community, we are also working with text, but it's different what we're doing in the Viz community, right? Here's a lot of examples, but they're mostly about starting with text and then extracting quantitative data out of the text. So I think we need to bring the qualitative in, and there's really 2 things that we need to solve. One of those is that we need areas for the text in the visualization, and then we also need to then fit the text into those areas. And here is a cultural map where the text is not readable on the screen, but this has words, phrases, sentences that are in here. And it's very similar to a Voronoi tree map, and it's got hundreds of sentences in it, right? So let's get to a specific example from data visualization. This is a tree map of oil exports. Size is proportional to the exports. Saudi Arabia is the biggest square, Russia is the next biggest. But we want to convey something qualitative about these countries. It's really hard to find a number to represent these different qualities about the countries. And so here we've just used the global peace index, ranging from countries that are more peaceful to countries that are worse. And you can see that we've got Saudi Arabia is red, Russia is worse than that, Iraq is worse than that. But you don't really know what is a global peace index, right? It's very opaque. It's made up of social, political, economic factors. You don't really have a sense of what's going into all of it. And instead, what we could do is just add text to that. So these are the first sentences from Human Rights Watch added to each rectangle in the tree map. And now you can actually read things like Saudi Arabia, we've got accountability issues with Jamal Khashoggi. Russia is the most repressive regime since the Soviets. UAE, which is a better color down in the bottom left corner here, actually detains dissidents after they've completed their sentences. And Canada, large, light, very light colored square in the middle there, they have issues with the rights of the indigenous people, right? So all kinds of issues can become very clear and apparent in doing something like that. I'll also point out that other representations have implied areas in their visualizations, right? So in a bar chart, the entire column of the bar is actually associated with the data. And so you could layer text onto something like that. And here we see the differences in cloud computing, that Amazon's strength is low cost, Microsoft is about things around ease of use, and Google is about things around machine learning. Those are important data points to understanding the why behind this chart, and it can only be expressed with qualitative text. So the previous two examples were focused on quantitative data as a starting point. What if our starting point is qualitative data? So the top example here is markup from NLP. We're indicating word salience on a classification model. We've got a quantitative score out of that. The second example, we're looking at summarization, and we're just marking and can't be seen as washed out on here. There should be highlights indicating the text that is being used in attended to specifically for creating the summary. And we might want to say, actually, there's a lot of non-quantitative tasks when we're working with text, right? So in reading and comprehension, we might be interested in moving back and forth through text, cross-referencing earlier passages, working with navigation. And so we could deal with some of those things using visualization techniques that we know, like aggregation and interaction. So here is a single chapter of Alice in Wonderland on a mobile device. I've used a large language model to convert every couple of paragraphs into a singular sentence. In this case, I used a model called Cohere, but similar to GPT-3, and just using a few shot technique to get these summary sentences. Then I've added interactions, so you can do things, again, washed out, but you can see it in a slightly smaller font, slightly lighter font, where a sentence has been expanded to its original full paragraph. And then you can also have interactions like tooltips on there to see what's going on and so forth. So this will work on mobile, this will work on a large screen as well. And what I've shown isn't perfect. There's a lot of open questions to these things. What happens when you get the really tiny areas on the tree maps? How can you put text in there? Would we want to use things like short words instead of long words, if that's what we're originally starting with as our point? And then we also have to worry about, what is the quality of the summarization that we get from the large language model? Even ignoring the latent information that we saw in the previous presentation, right? We still get things like this where we summarize text and it's jumping from the description into a summarization that says it's a war zone, right? So if we're doing something that's very accurate, it may be figuratively talking about a war zone, right? It's not literally in a war. So we have these kinds of issues coming out from the large model as well. And so instead of a conclusion, I'd like to end with a manifesto that basically says, why are we trying to quantify everything when we do visualization? We used to have an excuse that computation tools weren't really that good for manipulating text and preserving semantics, but they do now. And because they do now, it means we should be bringing qualitative data into visualization much more, whether it's quantitative or qualitative data that we're starting with. Thanks.
Hi, I'm Matt, UNC Chapel Hill. At the risk of self-promotion, I'm actually giving a talk on visualizing qualitative data in a couple weeks. And I was wondering, you mentioned this, there's this favorability of showing text data using concept maps, for example. But there are a lot of ways to show, for example, structured data like trees. What do you think it is about spatializing text data that sort of seems helpful for analyzing, interpreting text data?
So good question. I think if you want to, fundamentally in visualization, a big part of what we're doing is spatializing data when it's quantitative data with text data. Then we say, what is it that we want to spatialize, right? And the text may have various latent relationships, such as Marty's previous work on topic clouds and putting things in relation that way, spatializing it. But also the text itself has structure, so you do things like parse trees. There are all kinds of structures in the text, would be my premise. And those structures could be made apparent, even just in qualitative data.
Thank you.
Thanks.
I'm going to ask a really quick question
Okay.
while the next speaker queues up. So your premise was, yes, we need to have more text in visualizations, but often, we try to reconcile text into existing layouts. And I'm wondering if we should just rethink how, charts are created so that we make text more of a first-class citizen rather than the other way around.
Well, that sounds like a lead into the book that I just published. So yes, I certainly do think there are other kinds of layouts that we should consider. There are a couple in the book. The Alice example is driven by text. It's not driven by a
Right.
visualization layout. The tree map is force-fitting data into the tree map.
Right.
But there you could say the small squares, in fact, should have some way of being relaxed a little bit to give them some space to actually say something more than just 3 words.
All right.
Thanks.
Well, thanks, Richard. Next paper is called WordStream Maker, a lightweight end-to-end visualization platform for qualitative time series data, and Huyen is going to be presenting this.
Okay, hello everyone. Thank you for having me. My name is Huyen, and I am from Texas Tech University. I am a PhD candidate in computer science, and I am here today to present our work with my coworkers, Tommy Deng and Kathleen Bow. Our work is WordStream Maker, a lightweight end-to-end visualization platform for qualitative time series data. And first off, let me tell you a little bit of a story. So 3 years ago, in 2019, we present our work as WordStream at NLVIZ 2019. And this is the interactive visualization for topic evolution. And this is the combination of 2 very straightforward visualizations of word cloud and stream graph. And the WordStream addresses the problem of how to fit the text into the area, like one of the problems that the previous speaker just mentioned. And here is the evolution of the WordStream itself. So in 2019, the technique was introduced, and in the very same year, in the VAST Challenge 2019, so our team competed and submitted an entry for the VAST Challenge. And also another team used the technique of WordStream to visualize the social media data. In the following 2 years, 2020 and 2021, there are more and more applications built off of WordStream. For example, during COVID-19, WordStream was employed to visualize the sentiment and also the emotion analysis on social media in Peru. And in 2021, we had a chance to work with the typical form of qualitative data, which is the educational assessment. And the project is funded by NASA for visualization for science education as well. And in 2022, we have a brand new project of WordStream Maker. WordStream Maker is an end-to-end platform incorporating the NLP engine, and it is very lightweight. So the question is, why make it? Why making with the WordStream Maker? And what is it about an end-to-end platform and NLP engine that worth working on? So the first reason is the qualitative data itself. So whether it is the form of transcribed conversation, tweets, or blogs, qualitative data provides the reader with very rich insight into not just the trends, not just the patterns, but also the diversity of human ideas. And however, handling and analyzing qualitative data would require multiple time-intensive examination in order to identify these patterns. And when we couple with the time series element, the difficulty is even more. And to recognize the trends and patterns without losing the nuances or context is a very challenging task. The discussion with qualitative data researchers that we work with led us to the second reason. The user. We would like to consider the users from all backgrounds. And here is one question. Okay, word streams. It looks like it can be useful, but how much is the technical or programming background is required to use that tool? So the answer is it's quite a lot. So it involves the process of cleansing, merging, formatting, or data wrangling in general. And then because it is qualitative data, it is text data, then it requires the natural language processing part, such as part-of-speech tagging, name entity recognition, and tokenization, lemmatization. And finally, the visualization tool itself. WordStream is built with V3.js, a library in JavaScript. And the WordStream itself is currently a library in JavaScript. So it requires the user to know how to use JavaScript as well. And therefore, we come up with the idea of building an end-to-end platform incorporating all of these three modules, and to help the user, especially who are the ones are not from a technical background. So open the accessibility of this tool for everyone. And next up, this is the pipeline of WordStream Maker. So we started off with the raw data in a tabular form. And then it goes through three main blocks of the WordStream Maker: data wrangling, NLP extraction, text characteristic, before producing the WordStream visualization. And even at this point, the user can reconfigure the whole parameters to make the visualization as they desire. So for the data wrangling blocks, we have cleansing, formatting, merging. For NLP extractions, we provide the options for part-of-speech tagging, name entity recognition, tokenization, and lemmatization for visualizing the final visualization. For the text characteristic, it is how we would like to encode the information into the final text in the final visualization. It would be either word frequency, sudden change, RTF, IDF. Next up, we have the interface of WordStream Maker. So WordStream Maker, here we have three different panels. The first panel is for the input. WordStream Maker takes in tabular input in the form of CSV or TSV. Next up, after we load the data, the second panel is for the visualization itself. And then we have the configurations. The first block is for visualization options, the size of the chart, the height, and then we have the word count that you want to visualize. And the second group of options is for NLP. So we have the options to extract part-of-speech text with noun, verb, or adjective. Another option is for name entity recognition. The final group of configurations is representation matrix for the text characteristic. We have frequency, sudden attention, or TF-IDF. So the online platform, QR code, and the link are at the corner of the slide from this point on. Please give it a try, and if you please, let me know what you think. So here is the use case that we done the work with WordStream Maker. Here we compare different combinations of these two groups of configurations. We combine this and this. So in the first use case, we combine the part-of-speech tagging and the text characteristic of frequency. The second one is name entity recognition and frequency. And the last one is name entity frequency and sudden change. And we have some insight from this observation. First of all, name entity categorization works best for data from social media or written form of responses, such as educational assessment. Second of all, part-of-speech tagging can be employed for various domains because now verb and adjectives are very general categorizations of words. And however, the generalization can be too broad to form a coherent or specific insight, or if you want to bring out a very general theme of the data. So here is the analysis of runtime. So for example, a text file of more than 500 rows with a size of 1.5 megabytes. It would take less than 3 seconds to load and clean the data, run NLP extraction, and visualize the final word stream. So about availability, WordStream Maker is an open source hosted on GitHub. It is an online web application. And future development, we would really want to do sentiment and theme analysis to further support qualitative data research. So WordStream Maker, it is a lightweight end-to-end platform. It is to support qualitative data summarization, and it is an open source project. And this is the link to our applications. My name is Huyen. Thank you so much for listening.
So it's very interesting. So to calculate the envelope of this stream, do you use similar technique like Theme River? Like to the envelope, like for the stream, like this red, green, this orange, green, and blue?
Yeah.
Do you calculate like similar technique than Theme River? Do you know this technique, Theme River?
I'm not sure.
It's a very old technique from Pacific Northwest.
Oh, so this is mostly based on the concept of stream graph.
Stream graph, okay.
So the width of this one is the total frequency of the word at that very time point. So this is the horizontal for the timeline. And the width of each stream over here is the sum, is the addition of all of these term frequencies over text characteristic of all of the containing words corresponding to that time point.
I see. Yeah, it looks very similar to Theme River. You can look this up in Google. That's cool.
Thank you.
Thanks again for the presentation. And next up, we have Marcel Ruoff talking about towards interactively contextualizing natural language input in data visualization tools.
Then hello and welcome also from my side. My name is Marcel Ruoff, and today I will be presenting the insights from our paper toward interactively contextualizing natural language input in data visualization tools. This paper is a cooperation between the Karlsruhe Institute of Technology and the Carnegie Mellon University. As kind of like in our keynote introduced, natural language input has a lot of ambiguities. In our paper now, we focus on natural language inputs, which are identical, but have possible interpretations based on the context. So often we humans and also therefore of course the natural language interfaces need context to derive the correct interpretation of these multiple possible interpretations. For example, to continue with the select sum of amount invested, users in our formative study utilize this natural language input first to add value amount invested to values, to highlight it in the visualization itself, the amount invested, or just to change the aggregate of amount invested. So overall, our vision is that natural language interfaces are able to derive the correct interpretation from multiple interpretation, utilizing the context such as just shown in our context system. To achieve this, we first conducted a natural language elicitation study where we collected multiple natural language inputs and specifically focus on, are there any natural language inputs which have multiple possible interpretations? We then looked into how could we clarify these ambiguities, and first started with utilizing the probability, which only lead to the ability to clarify 42.7% of it, and then thinking about utilizing the context of the visualization, such as the data types, the current encodings, and the selections, which enabled us to clarify 71%. We then utilized these insights from our formative study to develop our context system, which I will be showing in the end. In our natural language elicitation study, we followed the following procedure. Each participant had to provide 2 natural language inputs which were intuitive to them for each of the 40 functionalities of the data visualization tool. We repeated this for 22 participants until we reached a large enough sample, and then looked into and tried to detect these ambiguities. We found that sometimes between participants that they use the same natural language input for completely different functionalities, but also the same participants sometimes utilize the same natural language input to utilize different functionalities of the data visualization to author it. In our results, however, luckily 87.1% of the results only had one meaning. Here we focus on ambiguities in regards of the number of meanings of identical. We do not look into things like earlier introduced, like the ambiguity of the data fields. Oh yeah, for sure. Yeah. And we had in this case these natural language inputs with only one meaning were well-defined natural language inputs such as a filter energy type for solar and wind. However, in my talk, I want to more focus on these natural language inputs which have multiple interpretations. So from them, still 12.9% of the overall natural language inputs of 22 participants had multiple meanings, but we were able to luckily clarify from the overall 9.2% utilizing the visualization state for natural language inputs such as like sum of amount invested. However, throughout this, when analyzing the data, throughout the formative study, the number of ambiguities have continuously risen. Yeah. Continuously risen. So we expect that, unfortunately, designers of NLIs can probably not predict and handle all the ambiguous natural language inputs in advance. So therefore, we propose to include the end user themselves to interactively contextualize these natural language inputs. We envision this in our context system, and I'm quickly demonstrating it for, again, our natural language input of select sum of amount invested. So in this case, we want to highlight amount invested in our visualization. However, the system incorrectly derives an interpretation which would lead to no changes, and therefore asks us to clarify its misunderstanding. We can do this And when doing so, the system will then ask us to demonstrate the correct interpretation of our meaning. It first provides its current interpretation as a visualization, which we could adapt. However, in our case, we will create a new interpretation and just highlight amount invested, which is also shown the result in the button of the visualization. We can then continue our training, but the system then provides us with the information that it would have a conflicting interpretation. As you can see, we have two with identical probabilities, so we would need to clarify it. It therefore asks us to provide certain statements on how it could differentiate the meaning, and helps us by providing statements based on our previous interactions and previously learned natural language interface or contextualization of natural language inputs. We can add this, and we can just play around to also hover over different aspects of the visualization, which can have additional meanings. When we're satisfied with our statements, which would describe this contextualization, we can press done and can now try out the new interpretation and check it out, in this case, for select sum of number of projects and test if it has learned anything from our contextualization. And as you can see, of course, in the demonstration, it has learned and is now able to correctly choose the appropriate interpretation. In our future work, we try to further improve and evaluate Contexted. First, we will be looking into how can we guide the users better in contextualizing these natural language inputs, as it's still a quite challenging task, especially for users who are not familiar with programming, as conditional statements are new concepts for them. Second, we want to qualitatively and quantitatively evaluate how successful these users can utilize the features of contextualize these NL inputs, and when and in which cases they choose to contextualize this, and in which they just ignore and accept a lack of interpretation. So thank you very much for your attention, and I'm welcoming any questions.
Thank you for your work. I think you built a wonderful user interface, but I wonder, do you evaluate the working or learning curve of the users to learning such tools by specifying their intents or disambiguate their intents? Because I see lots of the charts and lots of the text and the pop-up, and I wonder how the users perceive those. Mm-hmm. Yeah.
So to this date, we have not evaluated this system till now, but we have evaluated a different system which did not use the contextualization, but only the learning of new natural language input. And of course, it's still a learning curve in the beginning to first provide these natural language inputs, as it's in some case visual programming, which is challenging for these end users. However, already after the first completed explanation of these natural language inputs, they are quite familiar and can do it in a few seconds and express that, especially these suggestions and helps by the systems can accelerate this process itself.
Thank you for your answer. And from my point of view, I think if it is an elicitation tool to understand how people contextualize their input, then it's fine. If we want to build a system for that, it may need more careful designs how to lower this kind of learning curve of the, yeah. So that's my thought.
Thank you for your input.
I think we're out of time for questions for this, but thanks again for presenting this really interesting work. Next up, we have NL2 interface, which is an interactive visualization interface for generating natural language queries. And Yiru Chen is presenting.
Hi everyone, my name is Yiru Chen from Columbia University. Today I'm presenting NL2 interface, interactive interface generation from natural language query. This work is done by Ryan, Austin, Tianbao, Tao, and Eugene, and me, of course. So in old days, static visualization is the norm. But now, interactive visualization interface has changed. People rely on it to interact with data and can gain more insight from its interactivity. If you search COVID on Google, it will show such an interactive interface. Well, you can you can choose between case and deaths and different states and you can see the trends. And also in New York Times, most news now include interactive visualization interface. Despite we have so many interface creation tools like Retool, Tableau, Power BI, etc., building interface is still hard. No matter what tool you choose, building interface will go through 3 steps. The first is you need to figure out what the analysis is. Fundamentally, the analysis is what the interface expresses. Let's say if your analysis is date versus cases, and the interface can be a line chart showing the changing cases over time. And let's say if you add another analysis like date versus death, then your interface can have a button let you choose between cases and deaths and show the visualization correspondingly. We can see that the interactivity of interface is actually derived from the analysis varieties. The second step is to design the interface. For example, the line chart can be of different visualizations, say a bar chart, and the interaction, instead of button widget, it could be a drop-down widget as well. Then as to layout, instead of vertically, it can also be laid out horizontally. So for such a simple example, which only consists of 2 analyses, you can already imagine there are so many combinations, let alone complicated analysis. Finally, you will have to build and deploy the interface, which would be cumbersome. Since we are at this workshop, of course, we clearly want to turn natural language into interface. Imagine that people can ask a question like, what is the COVID cases or deaths per day? And the system can identify that a button can switch between the COVID cases or deaths. And a line chart can let you visualize the trend. And then it returns such an interface automatically to user. If we can do this, this would be a game changer. Folks in our community has done a lot of works from natural language to visualizations. For example, NL for DV, given a natural language like show average growth across genres for fictions, it will return you a static visualization. However, all this work are focused on single static visualization generation. How to turn natural language to interface remains very hard. So we propose NL2 interface, which is the first to try to generate interface from natural language queries. Let me show you an example. So first, users can choose to upload a database. Let's say we upload COVID here, and then given the database, you can ask a question like, what's the total COVID case a long time in Alabama? The system can notice that Alabama is of state attribute. Then it can generalize it and give you a drop-down widget here to let you choose from different states. And the line chart will update automatically. We can reset the interface. And afterwards, you can ask another question, what is the total case or death across all states in US? NL2 interface will notice there is an or in the question, so it generates a button to let you switch between the case and death. So when you're clicking the case here, it will show the case distribution. Similarly for death. Furthermore, you can append another query like, what is the COVID case per day in different states, say Alabama? Although you are only asking about Alabama, it can generalize to all the states, and it will show the trend in this line chart below. And the NL2 interface also noticed that by clicking interaction on the first map can help you switch between the states. So technically, to translate NL queries to interface, we need to automate 2 steps. First is to translate NL interface to the representation of analysis. And the second is to design, build, and deploy the interface for the analysis. So let's dive a little bit into the first step here. So different from static visualization, interaction in interface encodes variation. For example, the button here encodes analysis variation, the date versus cases, and the date versus status. And eventually, such variation will come from the natural language query, like the case or death per day, like said by the user. Thus, we would require the representation of analysis in our system to encode the variation from natural language query. We now support 3 kinds of natural language query: ambiguity, explicit varieties, and generalization. First is ambiguity. Given such a table schema and given such a query, what are the COVID numbers per day? We can see like the number here can either map to case or death because it is ambiguous and all these attributes are numerical. Thus, we encode the query as a representation of date versus cases or deaths. And the interface would use a button to switch between them. And if the question changes a little bit to what are the COVID cases or deaths per day, these queries would explicit an OR, which is explicit varieties. And here, the representation and the interface would be the same as before. Furthermore, here users wonder what is the COVID case per day in Alabama. Although it is especially asked about one state, we can generalize to multiple states by referring to the table attribute state is the main. Our representation would be date versus cases, while state equals to $state. Here, the $state means all the values in state's domain. And this can be expressed using a drop-down in the interface. So till now, we have showcased the representation of our analysis. In practice, unlike the simple one, I especially simplified for this talk, we model it on top of SQL because SQL is ubiquitous, and we term it as structurally parameterized SQL, or short for SPS. And luckily, existing work on large language model like Codex can help us translate NL queries to SPS. And from SPS, our previous work, PI2, can automatically generate a fully interactive interface with the consideration of visualizations, interactions, and layout designs. So in summary, NL to interface is the first to generate interactive visualization interface from natural language queries. And we also propose structurally parameterized SQL to encode analysis variations. That's all. I'm happy to take questions.
Hi, I'm Julian Chen from Harvard. So very nice work. So I have a quick question. I wonder, can you comment on like when the translation process is failed?
Translation from?
Yeah, I mean from the natural language to the SQL language. What if the model is wrong?
Oh, yeah, the model is you take from natural language queries and to our representation, like structurally parameterized SQL. So given we are give the in terms of how we do it, we give a Codex model some prompts, and the prompts are a pair of natural language query and the SPS representation. Mm-hmm. And we then the Codex help us predict what is the SPS for other unseen queries.
Oh, okay, thanks.
Yeah, for more detail, you can refer to the paper.
Hi, I'm Melanie Torrey from Northeastern. I noticed you used Boolean words like or as kind of keywords to to produce your interface. And I guess my question is, those could also be used to express things like filters in the natural language query. And the way that people use them is very ambiguous. And so how do you disambiguate yet the additional bit of turning it into an interface?
Yeah. So codecs, like we are not like specified all semantics, by especially here like to the analysis variations. Like if we just or in the future, then like codecs itself, its model like from natural language to SQL can identify that. So actually we are just relying on large language models, fine tuning and prompts, and hopefully it can achieve better. This is a very good question, and we also want to study that in the future and benchmark that.
Thanks.
Thank you again. Right, and as last paper for the session and the day, I guess now, is going to be speech-based data exploration for diabetes management among older adults. And Alok Joshi from the University of San Francisco is going to be presenting this.
Very slowly because all of you are ready to go. Okay, this is connected, but I don't see anything on the screen. Wait, I need to extend. Great. Hi, everyone. My name is Alok Joshi from the University of San Francisco, and I'm delighted to present our work on speech-based data exploration for diabetes management among older adults. I know from watching the stream that I shouldn't look at the screen. This work was conducted in collaboration with Vedangi Bhavsar, Utkarsha Nehe, Aditya Manke and Srushti Sardeshmukh from Pune Institute of Computer Technology in India. Now, as you may know, diabetes is a chronic disease that has affected more than 500 million people worldwide. And the World Health Organization predicts that the number of people older than 65 years with diabetes will reach almost 200 million by 2030. And 276 million by 2045. So we are talking huge numbers. On the other hand, smartphone ownership has grown rapidly among older adults from just 10% in 2011 to 61% in 2021. And older adults are using their mobile devices a lot more now for messaging, gaming, social media, and even audio video conversations using FaceTime, WhatsApp video, or whatever else. That's great. On the other hand, the quantified self movement has increased awareness regarding the need for more steps, more sleep, less stress, and actually even better control of blood glucose monitoring for patients with diabetes, which is great. And that's a good thing. And all this data, as we know, is accessible through an app. And all these apps are great, but they require things like filtering, pinch and zoom, maybe swiping some screens, tapping on a bunch of things. It takes a while to get the hang of it. And I know that I need at least 4 taps on my Fitbit app to look at how I slept the previous night and why I'm feeling groggy today. And maybe it's just jet lag. So that's a bit of a problem. Now, in his book about designing for an aging population, my colleague at the University of San Francisco, Jeff Johnson, mentions that older adults frequently have trouble interacting with the UI components on smartphones because nobody is building apps for older adults. They're building it for 20-somethings with lots of disposable income. He specifically mentions challenges with multi-screen navigation and motor control, among other things. And maybe some of you are much better than me, but I can't click that little X to close some windows when I see them. So the goal of this project actually was to bring the quantified self-movement to older adults through speech. And we wanted to develop an app that would allow older adults to ask questions of their data using the app. And the aim, the big picture aim, which we haven't yet achieved in this project, is that through a conversational interface, older adults can get a better understanding and maybe able to manage their diabetes a little better. So the first step was to actually talk to some older adults. So we conducted interviews to try and figure out what are some of the challenges that they face and what kind of requirements would they have for an ideal diabetes app. Like, what are the kinds of things you'd like to find? Or what would you use? And so we interviewed 7 adults in the 62 to 79 age range. And they were all residents of Pune, India, and with varying levels of type 2 diabetes. And this is relevant somehow, but patient self-monitoring was quite varied between once a day or twice a day to once every 3 months. And only 3 of the 7 patients actually owned a glucometer. Now, all of the patients had an Android device and most of them exercised regularly. So we kind of learned a little bit about this user group. We then identified some wireframes based on the requirements, and we iteratively worked with our participants to refine the design. And we identified that simple charts such as line charts are good and understandable. And we know that we also made sure that the symbol of the microphone was prominently featured to allow users the ability to ask questions of their data. So these are some of the visualizations that you can see when you use the app. So on the left, you're seeing the averages as well as the ranges over a user-specified duration aggregated over the days of the week. So here you can see, let's see if the mouse works. So the duration is between Jan 1st, 2022 to March 8th, 2022. And that data has been aggregated and represented in the form of days of the week. So here you can actually see that the average blood glucose level is highest on Mondays in this data set. Now, the right image actually does the aggregation based on the month. And so you can look at an entire year and some, and this performs the aggregation for whatever data you have selected or the user has specified. You can ask specific questions, and these questions are very, very specific. So you can just say July 2021, and then the user is actually shown the blood glucose level for the month of July 2021. Here we are showing line charts because, as we figured, line charts are easier to read, and our participants expressed that in the interviews. Okay, so this is simplistic. You can say things like, you can incorporate a little bit of conversational semantics and say, what about this January? And so the app will figure out what you're trying to ask and say, and show you the blood glucose level for the entire month of January 2022. You can also do some kind of simplistic comparison where you can say, you can specify the months that you want to compare or the duration. But in this case, we are specifying the month of February 2021 and March of 2021. And based on that, it automatically, let's see if the mouse is still here. It changes the date ranges. It changes the date ranges up here and shows the appropriate visualization with the mean as well as the range for those periods. So you can compare. Okay. To summarize, based on the interviews that we conducted, we developed an app that allows users to interact with their blood glucose data using speech. Users can ask questions about specific duration or compare two user-specified durations. And in terms of next steps, we plan to deploy the app with our older adults for a longer duration and conduct interviews to evaluate what they thought about the features in the app. And as we've discussed today, there are so many complications with speech interaction. And so, we want to try and expand that set of queries that are possible so that people can actually interact with it in a natural manner. And also identify some common linguistic structures that we can use. We'd like to thank Amar Buchade from PICT Pune, the Faculty Development Funds from USF, and the Data at Hand team for making the framework available. And with that, I will end my talk, and I'm happy to answer any questions. Thank you.
Hello? Okay, cool. So, yeah, this was really cool work. So, with this sort of approach, would you, so this, a lot of these like resulted in kind of setting up different like queries and stuff for visualizations, but they're all static visualizations. So kind of as future sort of work, would you say this would replace sort of interactive or like dynamic visualizations, or is there something where you could put this on top of a dynamic visualization for older adults?
So are you thinking like streaming visualization?
Or even just like a small like annotation that gives it a bit more information. So yeah, so is there some kind of mixture where you could have a more interactive dynamic visualization with this text, or do you think this kind of replaces the need for that?
No, I mean, I think it would work with dynamic visualization as well. I think, I kind of just want to get away from like clicking and tapping and all that, and try and let people explore those same functionalities, but using speech.
Cool.
There's no constraint there.
Thank you.
Thank you. I know. Thank you. Thank you.
And I know we're running a little over time. This is the only time when my ability to talk faster than speed of light comes into play. So hopefully we'll be good. I promise that was not me. Good. Yeah, it's on. Yeah. All right. How about now? Is that working? Yes. All right, great. All right, so send this up. Share. All right, yep. So just a super quick closing. We've had a lot of discussion after each paper, so if we sum that up, we'd have great discussion as well. But so if you have more questions, the authors should be around. Please feel free to reach out to them or email us, and we'll pass those questions along to the authors and make sure you guys get connected. Just a quick recap, we had a really great keynote today morning by Amit, and then 7 papers that followed after that. All the information is on the workshop website, so you can get the papers, and hopefully we'll also add links to the talks there once we get them after the conference. In terms of what's next, again, we had a more brief version of this last year where we were more like, should we have this version of the workshop next year? And the answer to that was yes, and we have more papers and more people attending this year. So thank you again for that. If you have any thoughts in mind about writing a blog post based on this, doing a CGNA article or some other format of this, or just any ideas in other ways we can discuss and engage in conversations about conversational interaction and other things related to natural language, make sure you reach out to us and we can take things from there. But really, we want to hear what you have to say about this and hopefully do more versions of this at WIZ and potentially other conferences, depending on the level of interest. Again, if you have feedback, that's our email, but if you want to reach out to Vidya or me individually, you can also do that. Bit of a shameless plug, we are looking for interns at Tableau Research. So if you're interested, please go ahead and make sure you reach out to one of us or just apply online. That being said, want to thank you all for attending. Thank you all the presenters for doing this live, many of you, and for the first time as well, and keeping everything on time, for answering all the questions. Thank you all. And also a special shout out to the 2 student volunteers during the session, Laura South from the Northeastern University and Arpit Narchania from Georgia Tech. Thank you all. And now you can all go to your dinner. Sorry about keeping that.